It has been a little while, but I thought it was time to bring back some videos just in time for the calculus test coming up way sooner than I hoped for. But here we go, let's do it anyway. Okay, first thing we're looking at is an overview of what the test looks like. You're going to have a bunch of multiple choice questions, 45 of them total. The first 30, you'll have 60 minutes to do with no calculator. And then after that, you'll have 15 questions for 45 minutes with a calculator. Those tend to be a little more conceptual, and you tend to not need a calculator for most of them. I don't really know why that's how they do it, but that's how they do it. But while you're on that section, just make sure that you're actually using your calculator when you need to. Don't try and take derivatives by hand or anything like that. Then we'll do the free response, which is 2 questions for 30 minutes with a calculator. And then we have our 4 questions, 60 minutes with no calculator. And during that time, you actually can go back to the first 2 FRQs. You just can't use your calculator anymore. So after that first 30 minutes, essentially it's a free-for-all on the FRQs, just no more calculator. Okay, some multiple choice tips. I already mentioned one. Don't forget to use your calculator while you have your calculator. You can use it to graph functions to find zeros. You can find where graphs change direction. And really importantly, you can use it to calculate derivatives at a point or definite integrals. That's going to be really, really helpful and time saving. And then if you're absolutely lost on some multiple choice question, compare the options. I know we've done those initial value problems and we looked at the answer choices and we're like, well, it's definitely this one just because they're 50 apart, which they were the initial value apart. So you can use some logic if you're just not sure what to do. Don't just panic and not think about it at all. Then we got some free response tips. Once you're on the calculator section, write down everything you do in the calculator. Don't just do the calculator thing, because writing down what you're doing actually gets you some of the credit. For example, if you are looking to find the zeros of a velocity function for some reason, make sure you write down v of t equals 0 on your paper, because that's showing the grader that you know that velocity needs to be equal to 0 for your question. Then the other thing, don't round until the very, very end. Keep those really long decimals all the way up until you have your answer, and then round to 3 places after the decimal. When you're on the no calculator section, you want to show all of your work. Even if you don't know what's going on for a problem, you can write something. If you leave it blank, it's definitely wrong. But you can always get some sort of points. My big example is the differential equations question. All of you know how to separate the variables. You can do that, and that's one of the points. You can usually do the antiderivatives after that, and that's 3 of the 5 points on a differential equations question. So you can do something. And then if you need something in like part A of a problem in order to do part B, but you don't know how to do part A, try your best in part A. Whatever answer you get, use it in part B. It's a thing called error carried forward. They're not going to count you off twice for the same mistake. Okay, so we're going to talk about some of the ideas. This is not exhaustive. It's just the things that I see most often. So again, there are other topics that you need to make sure you know, but these are like the biggest things I see, though I could be wrong. First thing is limits. I see a lot of limits at infinity, so those are horizontal asymptotes. Indeterminate forms are 0 over 0 or infinity over infinity. Composite limits, which is a little strange. It doesn't come up that much, but I've definitely seen it. Our intermediate value theorem and some continuity ideas. Then in derivatives, we got like basic derivatives where we're just using product rule or chain rule or something like that. We've got the derivatives of the inverse functions. That's always at least one question on the test. The graphs ideas going from like f prime to f or f double prime to f, something like that. And then the mean value theorem. Some derivative application ideas that come up all the time, the related rates with the implicit differentiation when we differentiate with respect to time, that always comes up. Extrema, so doing our candidates test, our first derivative test and second derivative test. I don't see the second derivative test come up that often, but first derivative test and candidates test definitely are there. And then particle motion is a huge deal on the test because it relates derivatives and integrals both. So our particle motion, it's got, like I said, it uses both derivatives and integrals. We're going to talk about speeding up and slowing down and total distance versus displacement. And then finally, integrals. We got our Riemann sums. We got our basic integrals where we're just doing like antiderivatives, or we're doing like plug in the bounds to your antiderivative or u sub. Taking derivatives of integrals, that comes up a lot, especially on some FRQ questions. Initial value problems, differential equations, volume. There's a lot to be done in the integrals section. And then we've got a couple BC only topics. We've got series, which every BC student loves series. Our tests for convergence, manipulating some known series, finding intervals of convergence, error bounds, and conceptual questions. Those conceptual questions in series almost always have to do with finding the coefficient of like the third degree term or finding the third derivative, something like that. We've also got parametric equations. So total distance traveled, arc length, speed, finding other vectors. So like say you've got the velocity vector, they want the acceleration vector, something like that. And then polar coordinates, which mostly is finding area. If it's strictly polar, it's almost always just find the area. But sometimes you also have to find dy dx, and there will be some ties to parametric equations. Something else BC I didn't mention, there's a couple more integration methods we have. So we've got the integration by parts, we've got the improper integrals, the logistic differential equation, and then the Euler's method. So there's just a couple more things I didn't have put into the slides, but that's pretty much all the topics I'm going to try to cover in the like 10-ish videos. So look forward to doing a couple more. Love you all. It didn't work how I wanted it to.